We're going to solve a different triangle now with a different set of information. We have triangle RST, and we know three pieces of information with this triangle. We know side R is 14, we know side S is 5, and we know side T is 18. So again, to get an idea of what this looks like, I'm going to draw out a triangle, and knowing that T is our longest side, I'm going to place that down here on the bottom just because that looks like my longest side with how I drew it, which means angle T is going to go up top. Second longest side is 14, so I'm going to put that over here. That's angle R. And then my last side is 5, which would mean this over here is S. Angles and sides of the same letter always cross from each other. Now with all the other triangles that we've solved, we've known an angle and at least a side, but here we don't know any of the angles. All we know is the three sides of the triangle. So we definitely cannot use the law of sines, because with law of sines, to create that ratio, we need a value for an angle and a value for a side. But without knowing any of the angles, I can't create those ratios. So I'm going to rely on cosines again to help me out. And just as a reminder, the law of cosines tells us that a squared plus b squared minus 2 times a times b times the cosine of c is equal to c squared. Now, we don't have a's, b's, and c's, but we can still do this recognizing that the angle that we're using here is formed by the a and b. So depending on which angle we want to find, we can use different pairs of sides to do that. I'm going to start with the largest angle because the law of cosines can always give us obtuse or acute angles. So with 18 being our longest side, angle T is going to be our largest angle. So I'm going to find angle T and place that in here for the cosine. So cosine of T. That means if I'm finding angle T, I need to use the two sides, the 14 and the 5, that form it as my A and B values. So this will be minus 2 times 14 times 5, and I can do a 14 squared plus 5 squared out in front. And then the only side we haven't used, the 18, is the one that goes over here by itself as 18 squared. And now we need to start to move things around. So 14 squared plus the 5 squared out front, if I combine these first two, ends up giving me 221. If I multiply the 2, the 5, and the 14, this will end up being a minus 140 times the cosine of t is equal to 18 squared, which gives me 324. And now that I've set that up, I can't subtract these two. That 140 is connected to the cosine as a coefficient. I need to move that 221 off. So if I subtract the 221, those are gone. I end up getting negative 140 times the cosine of t is equal to 103. To remove the negative 140, I can divide it off and say that the cosine of t is 103 divided by negative 140. And to finish that off completely, I need to get t by itself, so I'm going to use the inverse of cosine and say that t equals the cosine inverse of this 103 divided by negative 140. And I'm going to leave it as a fraction there when I type it in the calculator, so it's a little bit more exact. So the inverse cosine, 103 divided by negative, ends up giving me a 137.4 degree angle for angle T. So up here I can fill that in, 137.4. Now the nice thing about what we have now is we do have an angle side, and we'll find another angle with one of these sides using the law of sines. And it's a little bit simpler formula. But for the sake of practice, I'm going to set up another one using the law of cosines, so that we can make sure we know how to move things around and solve for those angles. And it doesn't matter which one we go for. I'm going to solve for angle R here, so that we can figure out how big that is. If we're solving for angle R, we need to use the two sides that form that, the 5 and the 18, as our A and our B value. So in my initial setup, I can say 5 squared plus 18 squared minus the 2 times those same values of 5 and 18 times the cosine of the angle between them, which equals the side opposite of that squared, so 14 squared. And I can't just type everything into the calculator because I don't know what that cosine value is. So I need to take this in pieces and say, what are these two combined and what are these combined? So if I take 5 squared and add 18 squared to that, I end up getting 349. If I multiply the 2, the 5, and the 18 together, I get 180 that I'm subtracting off. So that's attached to the cosine of angle R, and then equals 14 squared, which is 196. So at this point, now that I've got my squared values combined, my coefficient combined, I can start to move things off and isolate that R value. So I'm going to start by subtracting off this 349. So if I take 196 minus 3, I end up getting a negative 153. Those are gone, and that equals the negative 180 times the cosine of R. To get rid of my coefficient, I'm going to divide off that negative 180 to get rid of that. So the cosine of R equals the negative 153 divided by negative 180. And the two negatives are going to divide out, so those can both become positive. And then I need to get rid of the cosine using its inverse. So R is equal to the inverse cosine of that fraction, 153 divided by 180. And if I type that in, inverse cosine 153 divided by 180, I end up getting a 31.8 for angle R. So 31.8 for that bottom right angle. And now that I have two angles here, to find this third one, I can take 180 and subtract two angles, the 137.4 and the 31.8. And I end up getting a 10.8 degree angle for that final one. So when we have just three sides initially, like we did here with the 5, the 14, and the 18, the only thing that we can do with what we know so far is to set this up using the law of cosines. I don't have any ratios between the angles and sides to use the law of sines initially, so I have to use the A, B, and C here in the law of cosines to help me solve for some angle C. And we started here with angle T just because it was the largest of those angles, and the law of sines can't solve for